Welcome to the Math Record. Today I'll be covering the ICTM Regional 2017 Geometry Division A. Okay, let's begin. So, number one, a 5-inch wide by 8-inch tall photograph is enlarged proportionally into a poster that is 40-inch tall. Determine the number of square inches in the area of this poster. Right? So, you enlarged it from 8 inches tall to 40 inches tall. So that went up a scale factor of 5, right? So, you kind of have to draw this out. What it kind of looks like is we have a picture that looks like this, and then an even bigger picture, right? So we have something that's 5 inches to 8, and now it's 40, right? So if it scales up, 8 times 5 is 40, so 5 times 5 is 25. So the area of this is 25 times 40 is 1,000. So that's your answer for number 1, 1,000 square inches. If you want to put the units, you could, but you don't have to. So number 2, triangle ABC is isosceles with a AC, right? So let's kind of draw this out. So this is AC, and this is B, right? And this is isosceles. And you have, and AC is length 12 square root 3. Okay. The numerical area is 36 square root 3. Okay. So what is the angle of ABC? Okay. So let's kind of think about this. 12 square root 3 times the height, right, divided by 2 is equal to 36 square root 3, right? That's just the basic area formula. So then we know that h, so 36 times 2 is 72. 72 divided by 12 is 6, right? Because the square root 3 is going to cancel each other out. So h is 6. So we know our height is 6. So let's kind of erase this. Let's erase that part. So if we draw the height, that's 6. Since this is isosceles, this side is equal to this side. So that each of these sides, or since this entire thing is 12 square root 3, that means each of those sides is 6 square root 3, right? So this is just something you have to know. If you have something, we have a right triangle, and this is x, and this is x over 2, and this is x squared root 3 over 2. This side is going to be the 30 degrees, and this thing is going to be the 60 degrees. It's commonly referred to as the 30, 60, 90 degrees triangle, right? Because you have 30 degrees, 60 degrees, and the right triangle is 90. And that's why it's just one of the most common, aside from the 45, 45, 90, which is just isosceles right triangle, right? So we know that the square root 3 is usually going to be where the 60 degrees is. So we know this is 60 degrees, right? And since this is isosceles, right? If this is 60 degrees, this angle is also 60 degrees. So to determine the angle of ABC, B is just that 60 plus that 60. So the entire angle is 120. Even though the picture doesn't really show it, it is 120. It's just that my picture is kind of bad. So the angle is 120 degrees, which is your answer. Number 3. A regular hexagon is inscribed in a circle of a radius 8. Determine the exact area interior to the circle but exterior to the hexagon. Right? So you have a circle, and a hexagon is inscribed inside it. So we have a hexagon inside. So we have something like this. And it says a regular hexagon too, right? So a regular hexagon means all the side lengths are the same. And the radius is 8. Okay? So we make a center, and then it goes from one of the vertex is 8. So if you kind of draw a angle to it, we know that since there's 6 sides, right? If you draw like each point, right? We have 1, 2, 3, 4, 5, 6, right? We have 6 triangles. So we know a interior angle of a circle is 360, and there's 6 sides, right? So 360 divided by 6 is 60. So we know one of the sides is 60. Okay. So let's kind of just break this down. So we're gonna rotate that a little bit so we get right here, right? So that's 60. And we know each of the side lengths is 8, right? Because this is 8 and this is 8. Okay. So as I said before, um, let's split this, right? So it's right in the middle, so it's isosceles. So that 60 becomes a 30. That's an 8. That's an 8. So that becomes a 30, and this also becomes a 30. So as I said before, you kind of have to remember the 30, 60, and 90 triangle, right? So the opposite of the 30 is just half the hypotenuse. So it's 8, half of that is 4. Half of 8 here, that's also a 4, right? Which is basically 8, 8, 4 plus 4 is 8. So this is just the equilateral triangle, right? So the opposite side of a 60 here is 4 squared root 3, right? Because it's just half of this, so half of 8 is 4, and then you have to multiply by square root 3. Okay, so our area is base, which is 4 plus 4 is 8, times our height, which is 4 squared root 3, divided by 2, right? So 4 divided by 2 is, 8 divided by 2 is 6. 8 divided by 2 is 4. 4 times 4 squared root 3 is 16 squared root 3. So that's it. That's the area of one of these triangles, right? We have 1, 2, 3, 4, 5, 6, as I said before, right? So now we need to multiply that by 6, because that's just area 1 triangle. We need 6 of them. So 16 times 6, that's 96 square root 3. So that's the area of our hexagon. But what's the area of our circle? Well, it's pretty simple, right? We already got the radius is 8, right? So the area of a circle is pi radius squared. So the area of the entire circle is 64 pi. So the exact question is that determine the exact area interior to the circle but exterior to the hexagon, right? So the area inside the hexagon is this entire area is 96 square root 3, and the entire circle is 64 pi, right? So you want the area of these shaded parts, right? Okay. So those shaded parts you have to add together. That's just 64 pi, right? The entire circle. And then minus the hexagon part is the part that is in the circle, but is exterior to the hexagon. So your answer is actually 64 pi. I usually write pi's like this. Okay. You just write pi. 64 pi minus 96 square root 3. And that's your actual answer. The exact answer. So don't use your calculator to do any rounding. You have to write this exactly to get full points. Well, to get the point. It's only 1 point. So, number 4. Currently, 30 students at small town high school are taking at least one math, English, or history course. Okay, so this usually on these questions is like a Venn diagram, so I just do a Venn diagram. Okay, so we have math, English, and history. Math, English, and history. 6 students are taking all three, so 6 is right in the middle. 14 students are taking English, but there are no students taking only English. So there's 0 here because no students are taking only English. And 14 students are taking English. So this section plus this section plus this section is gonna be equal to 14. But we have 2 unknowns, so let's kind of not focus on that yet. 14 students are taking math with 4 only taking math, okay? So only 4 of these are taking math. And 14 is taking math in total, but we don't know what these twos are, so we're not gonna put it in. So 10 students are taking only history. And 10 students are right here. And 16 students are taking history or math, but not English. So history or math, but not English. So we have 16 students of that. So, okay, so we have this 4 plus 10 plus this section is equal to 16, right? So this section has to equal 2. Okay, so let's go back to the math portion. 14 students are taking math. So we have 4 plus 10, 6 is 10, plus 2 is 12. But there's 16, right? So this part is 4. Okay, now let's go to English section back. 14 students are taking English. So 6 plus 4, that's 10, plus another 4 here. Okay, so determine the number of students taking math and history, right? Math and history, but not English. So the answer is 2, right? So math and English, but not history. Math and history, but not English. So the answer for number 4 is 2. So all you have to do here is just make a Venn diagram. Number 5. The sum of lengths of two diagonals of a quadrilateral is 44. Determine the perimeter of a quadrilateral formed by joining the midpoints of the consecutive sides of quadrilateral A, B, C, D. Okay, so we have a quadrilateral. Let's do something like this-ish. Kind of doesn't really matter. Now, the sum of the two diagonals, right? We have a diagonal here and diagonal here, and you add these two lengths, that's 44. Okay. So determine the perimeter of the quadrilateral formed by joining the midpoints of consecutive sides of ABCD. So what they mean is if we make the midpoint right here, midpoint right here, midpoint right here, and midpoint right here, and you make lengths that goes through every single one, right? You add all those lengths together, this length plus this length plus this length plus this length, you get you get that perimeter. So what's that perimeter? Well, since the only thing you're given is 44, usually if you're guessing, you probably want to put 44, which is the correct answer. So the reason why it's the correct answer is that let's kind of use a red, right? So we have to have the diagonals, which they talked about in the beginning. Okay, right? So what this is kind of showing is that if you kind of make the midpoints, we know that this line has to be parallel to this line. It has to be true. Because if we make a midpoint between those two lines and we make a line here, it kind of has to be right. This is the entire. If you make a triangle and you put right the midpoints, that means it's scaling by the right amount, right? So these two have to be parallel and these two have to be parallel, and well, this has to be parallel to this, which has to be parallel to this, and this has to be parallel to this, which has to be parallel to this. Okay. So what that kind of tells us is that if you add this length, right? So we kind of just could think about this in like symmetry. We could think about this length is equal to this length is equal to this length is going to this length, this is this, this is this, this is this, and this is equal to this, and this is equal to this, right? So all lengths, if you kind of like move it over, it's kind of like the same thing, right? So let's kind of like use different colors to see what's happening, right? If we have something like this, and then I don't know, I'll just use red again. Red. And then use blue. I don't know. Then use green. Then use two more different colors, purple, right? So I'm just gonna show that again, right? This purple over here goes with this one. This purple over here goes with this one. This green over here goes right here. This green over here goes right here. Oops, sorry. Goes right here. Right? And then the red ones, okay? This red one goes right here, and this red one goes right here. And then you have the blue ones. This blue goes to this one, and this blue goes to this one, right? So overlaps. So that's why if you kind of add the lengths together of if you find the sum of the two diagonals, the lengths of the two diagonals and add this together, and then you connect the midpoints of each ones, both of those lengths have to be the same, and that's why it's 44. Okay, so that is just number 5. But if you're guessing, you should just put 44 because that's the only thing you could make sense. Okay, in triangle ABC, we have ray BF, right? So this length over here, BF, bisects ACB, right? So this angle right here has to be equal to this angle. So CE bisects ACB. So it's basically the same thing on this side. So this angle is equal to this angle. So then BG bisects ABF, right? So what I'm guessing for the next ones is that this and this are the so this 1/4 of the area, this 1/4 of the area, this 1/2 of the area. I mean, not area, the angle, right? So then they all add up to like the whole area for the whole angle. Sorry about that. And then you have 1/2 of this, and then a fourth of this, and a fourth of this on this side. And then we know BAC is 40. So determine the angle measure of BYC. So usually questions are kind of like proofs, but usually I don't like to do the proofs because based on proofs on contests, it's almost guaranteed that they're gonna work. So we don't have to think too much about it. So what we had to do is that we could kind of just choose like some random angles because it always had to work. If it's a proof, that means it's usually these proofs or like these theorems that make sure that all them it works all the time. That means we don't have to like actually prove it. We just have to find the answer. So we know that BAC is 40. and we need to find this angle right here. Okay, so let's think about this. So let's kind of choose like two pretty decent angles because we know 40 plus this angle has to be 180, right? Because it's a triangle. So let's choose two really simple angles. Let's say 40 and 100, right? So that's 40 plus 40, that's 80, plus 100, that's 180, okay? So we know from the given information that this section plus this section is the same, and this section is the same. So we know this entire thing we wrote as 40, and this is 100, right? You could choose any ones. I'm just using these because it works out really nicely. So we know that's a half, so that's 20. We know this half of here is 50, right? Half of 50 is 100 is 50. And you know these are quarters, so we have 20 left, so that's 10, and that's 10. And we know these are quarters, so this is 25, and this is also 25, right? 10 plus 10 plus 20 is 40. 25 plus 25 plus 50 is 100, right? So 20 plus 50, that's 70. So this has to be a triangle, so this is 110. So this entire thing right here has to equal, since it's a circle, right? It equals 360. So that's 110. So this is 250 by itself. So we know 10 plus 25 plus 250. That's 275 to 85, right? And then we have this angle, which we need to find, plus x, right, is equal to 360. And we know x now is 360 minus 285, so that angle is 75. So answer is 75. You can use this with any angles. Like if you switch this to like a 50 and you make this like that's a 90, make this a 90, it's still gonna work, like no matter what. It's just that I just chose those numbers randomly, but since it's a proof, it has to work. So generally you don't have to prove it, you just need to plug in some numbers. And that's usually how I do it to save time. Number 7. In the diagram shown, O is the center of the circle, and AB lies on the circle with points A, O, B, C collinear, and CD is tangent to the circle at D. And DC is 12, BC is 6, and circumference of O is K pi. Determine the value of K. Okay, so let's kind of draw this out. And we have something like this circle. Okay, so they say DC is 12, so this is 12, and they said BC is 6. Okay, so determine the value of K, so we need to find the circumference. So we know this is the radius and this is also the radius, right? So the formula for these circles is called inscribed circles or inscribed lines or whatever they're called, but generally it's just inscribed. So the formula is that this entire length, which is r plus 6, is 2r plus 6, multiplied by the line that's outside, so pi the 6, is equal to this line squared. So it's equal to 12 squared. Uh, so that's equal to 2r plus 6 is equal to 12 times 12, which is 144. Divided by 6 is 24. Well, you just have 12 divided by 6 is 2 times the 12 is 24, right? So 2r is equal to 18. So radius is equal to 9, right? So the circumference is just 2 pi radius. So radius, put it in here, that's 18 pi. So k pi is 18 pi, so k is equal to 18. And that's your answer for number 7. Basically just that simple. You just need to know your formulas. Okay. 8. An octagon has 4 pairs of congruent interior angles. Okay, so we have 4 angles are this. We have 4 pairs of congruent angles. So there's 4 like different angles. I yeah, right? And then each of them have another one that's the exact same. The measure of each of the largest angles is twice the measure of the second largest angle, right? So let's say our largest angle is x, right? There's a pair of them, so there's 2 of them. And that is twice the measure of each of the second largest pair angles, which, right? So that means our second largest is x over 2, right? Because our largest has to be 2 times bigger than the second largest. The measure of each of the second largest is twice the measure of the third largest, so that means x over 4, x over 4. So we have 2 more angles, so we have 6 angles in total right now. And finally, the measure of the third pair is twice the measure of the fourth pair, so x over 8 and x over 8. Okay, so these are our 8 pairs. So and then determine the measure of one of the two largest angles. So we have to find the measure of A because that's the largest angle. And we know all 8 of these angles add together equals the sum of the interior angle of a hexagon, which is just 180, 8 minus 2 times parentheses 8 minus 2, right? Because that's to calculate the amount of sum, if n is equal to the amount of the amount of sides, right? The number of sides, it's just 180 n minus 2. That's the formula to find the number of total angles, right? So a triangle has 180. A triangle has 3 sides, so 3 minus 2 is 1, times 80 is 180. A square has 4 sides, right? So 4 minus 2 is 2. 2 times uh, 180 is 360. A triangle is made of 360 angles, right? 360 degrees, right? So this formula always works. So we have x plus x over 2 plus x over 4 plus x over 8. So that's just 1 plus 1 half plus 1 fourth plus 1 eighth, and they're all x's, right? So that's 4 over 8, and that is, oops, sorry, that's 8 over 8, that's 4 over 8, this is 2 over 8, and that's 1 over 8. So that's 12, 14, 15, 15 over 8, okay? So since there's 2 of them, it's 15 times 2, so that's 30 over 8. And then that's x is equal to 180, 8 minus 2, right? So our x is equal to, using your calculator, because we can save time that way, 8 minus 2 is 6, 6 times 180, and then times an 8 divided by 30. And we get an x that's equal to 288. So our answer for 8 is 288, because that's what we need to solve for, x. Okay. Number 9. Distinct points A, B, and C are collinear with B between A and C. Okay. So AB, which is square root 7 minus k, BC is equal to k plus 1, and AC is 4k minus 3. Determine all possible values for k. So they say B is between A and C, right? So let's kind of draw like a general thing. So we have A, we have a B here, and we have a C. So we know AB is square root 7 minus k, and we know BC is 2k plus 1, and we know AC, which is the entire thing, is 4k minus 3. Right? So it's given that 7 minus k plus 2k plus 1 is equal to 4k minus 3. Okay, so we know that's true. Let's move this up. So what I like to do, because there's a square root, I like to move everything to the other side. So 7 minus k. So 4k minus 2k, that's 2k. Negative 3 minus 1, negative 4. Since there's a square root, we need to square both sides, so that's 7 minus k is equal to 2k times 2k is 4k squared. Minus 8k, that's minus 16k, and that's plus 16. Okay, so I just squared both sides. And now simplify to quadratic, so 4k squared, and then negative 16k plus k is equals to plus 15k. I mean minus 15k, minus 15k. And then 16 minus 7 is equals to plus 9, right? And that's equal to 0. Okay, so we have 2k, 2k. Usually what it's either 1 and 4 or 2 and 2. I usually use 2 and 2 because 1 and 4 sounds kind of weird in my head. So might be a little weird. So let's see how that works. We have a 3. How can we split this up? Plus 4k plus 16. Okay. So we have a 3 and a 3. That's 6, and that's 12. That doesn't work. Oh, so it is a 4 and a 4. 4 and a 1. Okay. So it's not that. Okay. So usually it's just like double and checking, right? So it's not 2, 2, it's 4 and 1, right? So that's minus 3 on this side, and this is also minus 3. So that's minus 12, minus 3, that's minus 15. Okay, plus 9. Okay, that works. So k is equal to 3, or k is equal to 3 over 4. So we have two answers, but we need to check for extraneous. So which one? So usually one of them doesn't work. So we put 3 in here, right? We have 7 minus 3, that's 4. Square root 4 works. Okay, that's going to be a positive. That's a positive. And then that's a positive. Okay, so this one works for sure. Now we put 3/4. 7 minus 3/4, that's a positive. Square root of positive, positive makes sense. 2 times this, that's positive. Plus 1, that's positive. Okay, that works. 4 times 3/4, that's 3. 3 minus 3 is 0. Okay, AC cannot be equal to 0. It has to be 1 or above. It has to be greater than 0. It has to be positive. So this answer does not make sense. So the only possible answer is 3, because based on extraneous solutions. So number 9 is just 3. Okay, number 10. In the diagram below, M is parallel to N. Okay, so let's kind of draw this diagram out a bit bigger. And something right here. And degree angle 1 is 32, right? And they say they're parallel. And P is perpendicular, so these are right triangles right here. So we know this is 32. That means this angle is also 32. So if this angle is 32, that means this angle is a 58, right? Because 58 plus 32 is 90, because this is already 90 degrees. So to determine the angle for 2, so we need to find this angle right here, right? So since this is 58, that means this is also 58. Since this is 58, that means this is also 58. So our answer is just 58. Basically just that simple. Number 10 is just 58. You want to put the degrees, you could, but you don't have to. You usually just need the numbers. You don't really need the units, unless they specify you need it. Okay, the measure of the exterior angle of a regular N-Gon is increased by 9%. This angle is then equal to the measure of a exterior angle of a polygon with 2 fewer sides. Determine the number of sides in the original polygon. Okay, so if we have a polygon, the measure of an exterior angle is 360 divided by n is equal to the exterior angle. That's a general formula. So based on that idea, if we have 360 divided by n sides, we get x as our degrees. Okay, so it tells us that if this angle is equal to the measure of a exterior angle of regular polygon with 2 fewer sides, right? So 360. So 2 fewer of n is just n minus 2, but it increased by 9 degrees, so it'd be x plus 9. Okay. So what I first do is 360 is equal to n times x, right? I just rearranged it. And you do the same thing for this. So it's 360 is equal to n minus 2 times x plus 2. I mean x plus 9. Okay. So simplifying that out, we have a 360 is equal to n times x, which is nx, plus 9n minus 2x minus 18. That's a little bad. Okay, minus 18. Okay. We know nx is 360. So 360 minus 360 is 0, right? So 0 is equal to 9n minus 2x minus 18, right? So you can move 18 to the side. So 18 is equal to 9n minus 2x. So we know this has to be true. Okay. So let's delete all of this because we don't need it anymore. And we know this is true. So 18 is equal to 9n minus 2x. And we know 360 is equal to n over x, right? So we need to solve for the number of sides, right? So we need to find n. So let's substitute this x into here, okay? So we get just one variable. So 18 is equal to 9n minus 2 times 360 over n, right? And now we can multiply, let's multiply both sides by n. So it's 18n. 9n times n is 9n squared. And then 360 over n times n is just cancel out those n's. So then this would just be minus 720, right? And let's simplify this. Divide both sides by 9. So 18 divided by 9 is 2, and then that's n squared minus 72 divided by 9 is 8, right? 17, 9, 18, 36, 72. Okay, perfect. And now we're gonna have to make it into quadratic, so n squared minus 2n minus 80. That's equal to 0. Okay. Just a bunch of math and arithmetic to work on, right? So we can split this up, n. 10 and 8 would make that 2. So that equals minus 10, and that's plus 8. N cannot be negative, so n has to be equal to 10. So your answer is 10, right? It cannot be negative 8. You can't have negative 8 sides. So number 11 is, the answer is 10. Okay. Basically, no, not really that simple, but it takes a lot of steps. Okay. Number 12. In circle K, AKE is 60 degrees. Okay, let's kind of draw this out. We draw a line here. So AKE is 60 degrees. So since this is cut in half, this is 30 and this is 30. And AT is equal to TE. So this line is equal to this line. And HT is equal to 8. So from here to here, this entire length is 8. Find the and the area of sector AKE is 24 pi. So this entire area right here is 24 pi. Okay. So let's kind of remember that. That's an 8. Determine the exact area of quadrilateral KATE. So we want to find this entire area. Okay. So the area of a formula is pi radius squared, as I said before, right? But since you only have a sector of it, only this sector, this is the total degrees, and this is 60, right? Out of the entire circle, which is 360. So this area is only 1/6 of the entire circle, and that area is 24 pi, right? So pi divided by 6, well, pi radius squared divided by 6 is equal to 24 pi, right? So let's take out the pi because we don't need to think too much about it. So 24 times a 6, that's 144. So r squared is equal to 144. That means radius is equal to 12. Radius cannot be equal to negative 12, so radius has to be equal to 12, right? Radius cannot be negative, right? So we know our radius is now 12. Okay. So now all we need to do to find the area of this kind of quadrilateral is that since this is a kite, right? This is what the specific shape is. It's just this line times this line divided by 2 is equal to this area. So the reason that kind of works is because it's just this line times this line, right? So if we kind of draw the entire thing out, it's a rectangle, right? So this is equal to the height right here. This is equal to length right here. Length times height. Length times height is equal length is equal to the area, right? But we added these sides right here, right? So we multiplied. So we have 2 times the area, so we need to divide by 2, and that's why we had to have that length times this length divided by 2, and that would get us the area. Oops, sorry about that. So that's 30. That's 30. This is 8, and these two lines are the same. And you know the radius is 12, right? So as we used before, the 30, 60, 90 triangle, the opposite of the 30 is half that hypotenuse. So half of 6, 12 is 6. So this is also 6. And we know that this is also just the radius, right? So that's 12. So this entire length right here, entire length, that is just 12 plus 8, right? This is 12. 12 plus 8, that's 20. And the height is just that 6 plus the 6, which is 12. And then divide by 2, right? That will get us the answer. So 12 divided by 2 is 6. 6 times 20 is 120. So our area for our this entire thing is 120. Basically just that simple, which is number 12. 12 is 120. Okay. Number 13. Quadrilateral ABCD is located in the first quadrant of the xy coordinate plane, so that the point A is at the origin, D is at 16, 0. Okay, let's kind of draw this out. So we have a coordinate plane. A is at the origin. That's A. D is at 16, 0. So this is length 16. And AB is equal to CD, okay? And length BC is 4, and it's parallel to the x-axis. So we have BC, and that's length is 4. And BC has to, AB has to equal to BC, right? So this length is equal to this length. So it's an isosceles trapezoid. Okay? And the numerical area of ABCD is 80. Okay? Determine the coordinates of B. Okay? So let's kind of like rewrite this 16 a bit so we kind of get a easier thing to do, right? So we kind of draw these brackets, right? Since this length is 4 and this is a right and this is kind of like a right triangle. These are right triangles, right? That means if this length is 4, that means this length is 4. We know this entire length is 16, right? This length has to equal to this because these are isosceles, right? So this and this are the same and the heights are the same. So that means these two lengths have to be the same. Okay? So based on that, that means 16 minus 4 is 12. 12 divided by 2 is 6. So both of these are length 6, right? So how do we find the height, right? We need to find the height. So the height, we know that the area is 80. So 4 times the height is this portion of the rectangle. And now we gotta add both of these triangles, right? So 6 times h divided by 2, right? For this area. And then 6 times h, right? For this area, 6 times h divided by 2. And that entire area is equal to 80. Okay? So 6 times h divided by 2 is 3. H, which is the same thing for both these because they're the same. So 3 plus 3 is 6, plus 4 is 10. So that's 10 times h is equal to 80. So our height is equal to 8. So now we know our height is equal to 8. Okay? So determine the coordinates of B. So the coordinate of B is right here, right? That's where B is. So we have to move 6, right? Because there's 6 right here. So that's our x-coordinate. And we have to move 8 up because that's our height. So that's 8. So the coordinate of B is 6, comma 8. And that's just the answer. And that's it. Okay. Okay, question 14. A circular dart has an inscribed triangle. Okay, so let's kind of draw this out. So we have a circular dart. And we have an inscribed triangle. Well, it's an equilateral triangle, right? And that in turn has an inscribed triangle. So an inscribed triangle means circle means there's a circle inside that triangle. Okay, I'm not the best artist, but let's kind of make it a little decent. Okay, something like this. Okay, and we have the center of the circle. And the length of one side of the triangle is 12. Okay, determine the probability that the randomly thrown dart uh, lands on the dartboard, but also lands in the small circle. So what they're trying to ask is that they want to find the area of this smaller area of this small circle, and then find the area of the larger one, and then divide them, right? So the area of the smaller divided by the area of the larger. Okay. So how do we find the area of the smaller one? We need to find the radius. So warning, this question basically you need to know a bunch of equations. You don't need to know it, but if you know it, it goes a lot faster. Um, so what we need to know is that we have a radius inside it. This radius is referred to as the in radius because it's inside. It's the radius that's inside the triangle, and then we have a circumradius. This radius is this radius of the circle that's outside the triangle, right? So there's these two radius. So the reason we need to know this is that the in radius is basically going to help us find the area of the circle, the small circle, and the circumradius is going to find the area of the larger circle. Okay, so to calculate the in radius, the in radius is equal to the area of the equilateral triangle divided by 2 times, it's 2 times the area divided by the perimeter of the equilateral triangle, right? Not the circles. Both area and perimeter is of the equilateral triangle. So how do you find the area of an equilateral triangle? And this is another formula that you need to know, which is just x squared squared 3 over 4, right? So x is the side length. So the area of our circle is 12 squared root 3 over 4. Okay? So 12 divided by 4 is 3 times that other 12 is 36 square root 3. So our area is 36 square root 3. Okay, so 36 square root 3 times 2. And our perimeter, since this is equilateral triangle, that means all its side length is 12. So 12 plus 12 plus 12 is 36. Right? So our in radius is just 2 square root 3. Okay? So that's our in radius, 2 square root 3. I'm just going to record it up here. And now let's get our circumradius. So the formula for our circumradius, I'm just going to write circum, is equal to 4 times the, it's equal to, since triangle has side lengths A, B, and C, you're just gonna have to multiply all the side lengths. So it's A times B times C. And then the bottom is 4 times the area. Okay? That's the formula to find the circumradius. So the three side lengths of the triangle is 12, 12, and 12, right? Because they're all the same. So 12 times 12 times 12. Divide by 4 times the area. The area is what we already got, which is 36 square root 3, because we just got them like a few seconds ago. So 12 divided by 4 is 3. 3 times this 12, that's a 36. Cancel out this 36. And then we just need to multiply by square root 3 over 3, right? So this makes this a 3. So 12 divided by 3 is 4 square root 3. Okay, so our circumradius is 4 square root 3. Okay, and now we have everything we need. So what's the area of the smaller circle? It's just pi times radius squared, right? Our radius is 2 square root 3. That's our aim radius, right? So that's just pi. 2 times 2 is 4, times the 3 is 12. So the area of our small circle is 12 pi. And now our area of our big circle is pi radius squared. And this radius is now our circumradius. Right? It's going to be this radius now. So that's 4. That's pi. 4 times 4 is 16. Times 3 is 48. So this area is 48 pi. So the smaller circle over the larger circle, that is just pi divided by pi is cancel out. So 12 divided by 48, that just simplifies to 1/4. And that is your answer, 1/4. Right. For this question, you just need to know a lot of formulas. Okay. Okay, so we have a diagram, so let's kind of draw that out. Okay. So they say that AB is equal to CD. So this length right here is equal to this length right here. So that tells me that both of these are the same angle, right, overall. So they say that AB is in ratio 7. AB to BC is 7 to 4. So this is 7x to 4x, right? I put the x there so we could continue the ratios. So 4x. But remember, it said that AB is equal to CD, right? So if this is 7x, this is also 7x. Okay. And it also tells us that AD to DC is 6 to 5, right? So this side to this side is the ratio is, oops. So the ratio here, oh sorry, my thing is kind of not working, is 6y to 5y, right? But this is already 7y, so we just need to scale that to a 6 from 5y to 6y. So we just need to multiply by 6 over 5, okay? So 7x times 6 over 5. Okay, so that is just 42 over 5. 42 over 5x, okay? So what is the ratio of APD to CDP? So we have this A and B for these two small angles, right? So what's the ratio of A divided by B? So all we have to do is just the area of the angle of these small ones is just the larger one minus the smaller one and then divide by 2. So for this, for A, it's just 42 over 5 minus 7 divided by 2. This is just inscribed angles if you don't know what it is. If you want to search up on Google what they are. So 42 over 5 minus 7, that's 35 over 5. That's 7 over 5. 7 over 5 divided by 2 is 7 over 10. Okay, so A is 7 over 10. Okay, B is 7x. Is 7 minus 4x. So 7 over 4 divided by 2. Right, so that's 3 over 2. Okay, so now we need to find the ratio between A and B. So that's just, oh, I forgot the x's in here. X, 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 x. So now we have 7 over 10x divided by 3 over 2x, right? So the x cancels out. That's why we really don't need to do it. So 7 over 10 divided by 3 over 2 is the same thing as saying 7 over 10 times 2 over 3, right? So 2 divided by 2 here, that's 5. So that equals to 7 over 5 times 3 is 15. So our answer is 7 over 15. And that is our answer for, oh, sorry. That's just the ratio, 7, 15, right? And now we have to add them together. So the ratio is 7, 15. So 7 plus 15 is 22. And that's our answer, because it's k plus w, right? So as I just shown, you need to read the question. So that's 22 for 15. Okay, number 16. Triangle ABC has points A, 1/3. Okay, since they're giving us coordinates, I'd like to draw a coordinate plane. So A is at 1/3, somewhere around here, A. B is at 5, -2, so somewhere around here. C is at -2, 4, so -2, -4. That's C. Okay, so let's kind of connect them together. And those are our 3 points. Let me do a little darker this, right? Determine the largest of the 3 angles of ABC. So which one is the largest angle? So the general idea is that the largest side has the largest angle, equals the largest angle. That is always true. So what that means is basically whatever where the side is going to be the largest, right? So hypothetically, if this side is the largest, right, that means this angle is the largest. Okay, so if this side is the largest, then this angle is the largest, right? If this side is largest, then this angle is the largest, right? So the opposite, wherever the side is, go straight towards it, and that angle is the biggest. So all we need to do is just find the hypotenuse, the length of each of them, right? So this one's at 1, 3. This is at 5, comma, -2, and this is at -2, -4. Okay, so this length from C to B, that's just a difference of, the x is just a difference of 7, and the y's is a difference of 2. So 7 squared plus 2 squared. That's 49, that's 2 squared, that's 49, that's 4, that's square root 53. Okay, so this side length is 53. Okay, now A and B, that's a difference of 4 in the x, so 4 squared, plus a difference of 5 in the y, so that's 5 squared. Okay, so now we need a square root. So 16 and 25, that's 41. Square 41. Okay, now A and C, difference between the x, -2 and 1, that's 3 squared. And then difference y, -4 and 3, that's a 7, 7 squared. So that's a 9, and that's a 49. So 49 plus 9, that's 58. So that's equal to square root 58. So the largest length is square root 58, right? There's square root 58, square root 53, and square root 41. Square root 58 is the largest, which is on this side. So the largest angle is on the opposite, which is at the B, right? So your answer is just B. Basically, just that simple. Okay, number 17. In triangle ABC, let's kind of draw this over again. A, D, C, and B, and E. Okay. And they say DC is parallel to DE and BE, and AD to DB is 3, 2. So the ratio is 3x to 2x. And the ratio of the area of ADC to quadrilateral DCE is K to W. So this area is K, and this area of this quadrilateral is W. So the area of this is, if we had to think about this as an area, right? If ADC is K, right? Then the area of ABE, the bigger triangle, is 5 over 2. Sorry, that's 5 over 3 squared, right? So whatever that proportion is 3x plus 2x, that's 5, and then 5 over 3, because that's the entire length over this length, and then squared. That's a general formula that you just need to know of how to scale areas. So this big area, which is k plus w, is equal to this. So that's 25 over 9k. So you minus that k, because this is just k by itself, so minus that k, you get minus 9, so that's 18. Oh, sorry, not 18. We have 16 over 9, k. It's equal to w, right? So which is equal to our w. So the ratio um, for 17 between our triangle k to w, so k divided by w, we already know our w is 16 over 9k, so it'd be k divided by 16 over 9k, right? So this is just 1 over 16 over 9. So dividing is same thing as multiplying by reciprocal. So it's just 1 times 9 over 16, which is just 9 over 16, right? So the ratio for number 17 is just 9 over 16. You have to write syntax, so 9 colon the dots and then 16, and that's your answer. Okay. Number 18. The radii of two circles have respective lengths k and k plus 5. The difference in the area of two circles is 59.28 pi. Determine the value of k as an exact decimal. Okay. So the area of a circle is pi radius squared. So one of the radius is k, so it's just pi k squared. The radius of the other circle is k plus 5 over k plus 5.2. So the other area is pi k plus 5.2 squared. Okay. And they say the difference of these two areas is 59.28. So we have pi k plus 55.2 squared minus pi k squared is equal to 59.28 pi. Okay, let's move this up because those information is not necessary anymore. So we could just divide k from all the sides because we don't need it. So now we have, it's like a quadratic, so we have k squared plus 10.4k plus 5.2 squared. We could use your calculator for that. That is 27.04. And then we need to minus k squared. And that is equal to 59.28. Right? We minus k squared, so these two cancel it out. So we have 10.4k is equal to, then you have that 59.28 minus the 27.04. Right? We have 32.24. And then that means k is equal to 10 32.24 divided by 10.4, you get k is equal to 3.1 using your calculator. So that's your answer, just 3.1. Basically just that simple. Okay, just need to know the area of a circle, which is pi radius squared. Number 19. O and P are center of circles intersect at A and B that intersect at A and B to form a common chord. OP intersects AB at T, and the circles have radius 10 and 17, and OP is equal to 21. Determine the length of AB. Okay, so let's kind of draw a diagram out. Then we have a smaller circle, right? And then we have this. We have a center, center. Okay. We know and the radius of the two circles is 10 and 17, right? So the larger one's obviously going to be 17 and the smaller one's 10, right? So if we know this entire length from this circle is 17, but the distance that they give us at OP is 21, and this is 17, that means this length right here has to be a 4. Okay? So we had to draw a line. This length right here is a 4. Okay? And we know this circle is length 10, right? So if this is 10 and we know this entire thing is 21, that means this is 11. Okay? So that means 11 plus 4 is 15. And we know the entire thing is 21, right? So right in this middle is 6. But let's label this section from this point to this point is x, and this point now as length 6 minus x. Okay, so if we kind of draw two more lines right here, actually let's kind of use a different color because it's kind of a little weird to understand. So that's 6 minus x. Let's use red. Okay, we have a radius and we have another radius. This radius is 17 and this radius is 10, right? And let's label our height as h. So this is a right triangle, right? Which is for sure. So 11, so we have x here and 11 here. That's our length. So x plus 11 squared plus our height squared is equal to our radius squared, which is 17. So 17 squared. Now we have this length, which is 4 and 6 minus x. So add that together, that's 10 minus x squared plus our height squared is equal to our radius squared, which is 10 squared. Okay. So what we need to find is find a chord AB, right? Our height is just half of that. So we need to multiply by 2. So our actual answer we need to find is 2h. So we need to find h. So looking at our equation, all we have to do, let's kind of move this up because we don't need it anymore. Oh, sorry. Why won't this move? Okay. So we just need to solve this equation out, right? So let's multiply this entire equation by -1, right? So then when we add them together, we just have x plus 11 squared. We have a negative h squared here, cancel with this one, and then we just have to minus 10 minus x squared. And then 17 squared, that is equal to 289, I believe. Yep, and then minus 10 squared, which is 100. So we leave 189. Okay. Now let's expand this out and simplify. So this is x squared plus 22x plus 121. And this is minus x squared. That's minus 20. That's plus 20 then, x. And this is minus 100. And that is all equal to 189. Okay, let's move this up. So combine the x squared here is cancelled out by this negative x squared. So 20 plus 22 is 42x. And then that is equal to 189 plus that 100 minus the 121. So it's equal to 168. That means x over here is equal to 4. Because 168 divided by 42 is equal to 4. Okay? So we know that our x value is equal to 4, right? So actually, let's kind of move back what we've been doing. So we know, based on everything that we solved, we know our x value is equal to 4. So putting that back into our equation, let's use this equation up here. So 4 plus 11 squared plus h squared is equal to 17 squared. So h is equal to 17 squared, which is 289. And then 4 plus 11 is 15, so minus 15 squared, which is 225. Square root it. That means our height is equal to h. Height is equal to 8. So we know that means AT is equal to h is equal to 8. So that means our entire answer, which we are trying to find, which is 2h, is equal to 16. So that is our answer. Okay. So you don't understand what we've been doing. We have a large circle. Then we have a smaller circle. Okay. And this length was 11, I believe. And this was 4. And we cut right here. This length is x. This length over here is 6 minus x. And we made this from this point all the way to here. That is equal to h. And we know this length is 17. And we know this length is 10 because they're both radius, right? And then you just use the Pythagorean Theorem formula to make two circles and solve it like a system of equations. And that's all you need to do. So number 19, the answer is 16. Okay, so in a triangle with integer side lengths, the second side is 4 times the first side. So the first side, let's say our first side is x. That means our second side is 4x. And the third side is 17. Okay, determine the greatest possible perimeter for the triangle. So let's say 17 is one of the smaller sides. 4x has to be greater than x. So the inequality is that the two smaller sides add together has to be greater than the larger side. Okay, so 17 is greater than 3x. So 17 divided by 3 is be greater than x. Okay, so 17 divided by 3, that is about like 5.666 repeating, right, etc. Has to be greater than x. So x, they say that it has integer side lengths, right? So x has to be integer. So the largest possible x is 5. So if x is equal to 5, that means our three side lengths is 5. And then 5 times 4 is 20. And this is 17, right? So 5 plus 20 plus 17, that's 25. Plus 17, that's 42. So our answer for number 20 is just 42. Basically just that simple. Answer is perimeter. And that basically covers everything for the 2017 Division A Geometry Regionals, right? Thanks for watching. Actually, before I say we have to leave, as a review, basically the hardest I believe is probably 19 and 14. 14 is weird because you just need to know formulas. Other than that, everything else is pretty okay if you know what you need to do. But generally, for as advice for doing geometry, is that if there's a formula, it's to do a bunch of past exams and to use to just know formulas. Formulas will not help you. It will only help you in the long run because it will save you time. So mostly when you do competitions, you want to save time, and then to be precise also, but mostly just to save time, right? So then you usually just want to memorize formulas, right? So make sure you know the Pythagorean theorem, right? So the Pythagorean theorem formula. I'm not gonna write theorem, right? You need to know that. Make sure you know how to scale triangles, right? So questions like these, number 17. And make sure you know your in radius and your circumradius. So in radius and circumradius. I'm not gonna spell out. Actually, I'm going to. Yeah, circumradius. And make sure you know your inscribed properties. Uh, that's a R and an I. Inscribed. Inscribed angles and lines. Make sure you know those. And generally, that's basically it. A lot of things you could just do with common sense. Okay? And that's basically it. And also, need to know, this is one of the most important. The area of a equilateral triangle is x squared squared 3 over 4. This is one of the most important formulas you need to know. Just know it by heart. And that's basically it. Well, thanks for watching, and I'll see you at the next math record.